afternoon. My name is Teri Whitman, and I am a research scientist in the medical device industry for about 20 years now. And when I was sitting in your seat, I had never heard of a biomedical engineer, let alone aspire to be one. So in the next 5 minutes, I'm going to tell you kind of how I got here from there, and tell you a little bit about the journey that I'm on, because it's always, whether you're 17 or whether you're pushing 50, you always have something next, right, in your career. So I'll talk a little bit about what excites me for the next step in my career on some of my projects. So why didn't I know about biomedical engineering? My hobby, I grew up in eastern Wyoming on a cattle ranch, and my hobby was fossil hunting. I enjoyed picking up shiny rocks, and I thought, if someone could pay me to walk around for hours each day just looking down at the ground and filling my pockets with rocks, that would be great. But I didn't have any takers on that, and my parents always used to say, you're pretty good at math. When you start designing things, my mom would say, why don't you design something for the kitchen that makes sense? Because my stovetop was obviously designed by someone who's never cooked a day in his life, so why don't you go be a food engineer? I thought, all right, well, that's something. Everyone's got to eat, right? And I knew a little bit about meats and livestock, and I thought, I'll be a food engineer and go and build a better hot dog. That was what I was going to do. So I went to the University of Wyoming, and I have a degree in mechanical engineering, and from there I went to Purdue University to study food engineering because I was going to be a food process engineer. So I had one of those days in 1992 that changes everything, an afternoon that I was doing research in meat science, and I was looking at a particular problem called malignant hyperthermia. So this causes basically your skeletal muscles, so meat is certainly skeletal muscle going into that process that makes it meat. And when you have conditions that elevate the temperature in the meat, it can lead to quality problems. So this was what I was looking at, and I was a little stuck. So I was looking at things like pH and electrical properties, and I had results that didn't make much sense, and I've been reading some work by this guy, Dr. Les Gaddis, and he was in biomedical engineering. So I stopped into his office one afternoon, and he stopped what he was doing, listened to my problem, was as excited about meat quality as I was in that moment, and helped design a couple of experiments and some ideas that I could try, and even give me a circuit that I could use to measure electrical properties of tissue. And then he invited me to go on a tour of the lab. Come back, see what we're doing today. And so I did, and never seen anything like it. So that day, his colleagues happened to be running an experiment in electrical defibrillation. So this is putting an electrode down into the heart, and they were looking at different designs of those electrodes to see what would defibrillate the heart better. And I had never seen anything like it. You see it on television, they bring out the paddles, the chest jumps, you restart the heart, and that was going on right in the lab. And I thought, this is crazy. This is what fibrillation looks like, right? Your heart, your electrical activity of their heart goes from this nice sinus rhythm, P wave, R wave, T wave, to something very disorganized. And in order to bring it back into synchronization, you hit it with a 750 volt shock, and it kind of restarts everything. So that's what was going on that afternoon. And I say it was eye-opening and pretty dramatic, but at the time I thought, I don't know anything about this, it's a little bit foreign. But the last part of the tour that he showed me was an experiment, an invention that he had for monitoring babies, and it was to look at none other than malignant hyperthermia. So this also affects some people are susceptible to this, and babies under a certain kind of anesthesia can die, and it happens rapidly and fast, and babies die. And his invention was to head off babies dying from the same problem I was looking at for meat. he was looking at to save babies' lives. And I thought, oh, can I do that? I mean, I'm pretty passionate about my steak. I like meat. But I thought if I could work on something that saves lives, that would be pretty awesome. So that day, I asked, can I join your lab? This would be great. So I finished up my master's. Dr. Geddes worked with me finishing up my master's degree, and then I started a PhD in biomedical engineering. And Dr. Geddes' highest praise for an invention or an idea was that it was an elegant solution. So a simple idea that met the unmet need. And I think of this, he would use the example, like if you would explain it to someone, like your simple invention, and they go, oh yeah, that's simple, I could have thought about that. That's when you know it is the elegant solution. And you saw this just from Manny just a few minutes ago. So Dr. Geddes was a colleague, a friend of Earl Bakken at Medtronic, and he would call, in his class, he's like, Earl, this clever guy from Minnesota, came up with an elegant solution, which was this wearable pacemaker that would save a child's life when the power went out. And this, for me, this picture of the child and a pacemaker that he's wearing around his neck was sort of seared indelibly in my mind. Like, isn't that awesome? Like what engineers can do working with physicians and making something that saves lives. So from there, as we heard about earlier, the wearable pacemaker, in the next 60 years, went from something that you wear around your neck to this is what the pacer looks like in 2013, pretty small, and down below you see how the electrode, this lead electrode, snakes through the vessel and goes into the heart. But in 2016, we did some of this work down at the Visible Heart Lab here in Minneapolis, in the same lab that Earl Bakken had his first pacemaker. This leadless pacemaker went right into the heart. So this is designed to go into an adult heart because it's small enough to go through a catheter, but still too big for, say, a baby. So pacemakers in adults. This is the picture. Nice small electrode that goes into the heart. This is what it would look like under X-ray. So you see the X-ray on the front. You see the can, the pacemaker can, up in the pectoral pocket, and leads coming down into that shadow that is the heart. So what does it look like in babies? This is what it looks like in a baby. So instead of having this small little pacemaker, you see a pacemaker taking up most of the chest silhouette of a baby. And this happens, so if the baby makes it to delivery, they have to go in, open up the chest, sew on these electrodes, and you see a lot of that looping action. It's because a baby has to grow up to, a 3-foot child, and they put a lot of lead slack in there so the device can grow when the baby grows. So still not great, right? Because we've got babies that still need multiple surgeries to get them to 6'4" young men and 6 feet tall women. So, or 5'4" tall women. So what if we took the pacer that goes inside the heart, that is the micro device, and if you superimpose that device, now we're looking a little bit better. And what if the implant went something like this? So we'd take a catheter now. Remember, this is small enough. And instead of going inside the heart, we'd go outside the heart, take a catheter, go up. You can kind of feel your xiphoid process. You can access the heart right under there. You snake a catheter up and into the pericardial space. And we can look at this under X-ray while we do it. And then we use little fixation mechanisms on the lead to engage the epicardial surface of the heart. We do this without having to open up the baby's chest to implant it. And then we can attach the pacemaker right next to the heart. So no big coils, no big loops. And this is in a better position to kind of grow with the patient. So that's what I'm excited about next. It's not my only project, but it's certainly one that I feel pretty passionate about. And I want you, this is a great time of your life as you're looking out and wondering what to do. Find something that makes you passionate.
Thanks, Teri.